Hey guys, so I'm going to be talking about this thing called the law of reflection. What that says is that suppose if you have some lights hitting at I1 in the normal and it reflects off in IJ, I1 is theta I1 is equal to theta IJ. Now also light is also being refracted at an angle theta 2, which is not equal to theta I or theta J. But the index of refraction of the medium 1 times sine theta I is equal to the index of refraction of medium 2 times the sine theta 2, where the index of refraction is just the speed of light divided by the in a vacuum divided by the speed of light in a medium. So, but that's another topic which I will discuss later, maybe in next few videos, in the derivation of Snell's law, which is just this thing right here. So, since in this video I'm going to talking about the derivation of theta I is equal to theta j, which is the law of reflection. So I'm going to draw another diagram. Oh yeah, but first you have to find out in order to derive it, we have to understand one concept, and that's Fermat's principle, which says that light follows the path of least time in layman's terms. So if we draw another diagram right here, we find that if you take an arbitrary point big A, and you find out the distance to the surface, that's small a, and then from here to the more normal line, that's x. So and then if you take an arbitrary point B, which is just part of the light that's being reflected off, and take this distance as small b, and this is d minus x, and this whole distance is d, and this is medium 1, this is medium 2. We first find out the length. Now the length is, we use the Pythagorean theorem. This is a and this is x, right? So there's just square root of a squared plus x squared. And we find out this distance from here to from the origin to point B. Is that's just the square root of b minus x squared plus b squared and the square root of that, which is another Pythagorean theorem. And that's the light that needs to be taken. Now we want to find out the least path, right? Now in order to do that, you have to do something called optimization. And what optimization is that you take the derivative and find out the optimal point where, I don't know, suppose you're trying to find out the cost of this box relative to the volume of the box, and you need to find out the best volume with the best price. You have to use some calculus here. Or if you want to find another example, like for example, if there's a game going on, and then if you raise the prices, then there's going to be less number of people because some people can't afford it. However, if you lower the prices, then there's going to be more number of people. But and you have to find out like the optimal price such that you can get like the most money out of those people, and you have to use calculus for that. Well, optimization. And in order to do optimization, you have to first take the derivative with respect to x, since x is the variable being taken here, or the variable that I choose to take. So we do dl over dx, which is equal to this one. If you don't take calculus, then I suggest like learning like the simple derivatives to understand this. But this is the derivative. It's 1/2 times 2x over square root of a squared plus x squared. And then plus 1/2 times 2 times d minus x times negative 1 divided by 2 times square root of b squared plus d minus x squared. Because this is just to the a squared plus x squared to the power of half, so half goes to coefficient, minus half and a squared plus x squared. And then by train rule, you find the derivative of a squared plus x squared. A squared is constant, so you do derivative of x squared, which is just 2x, and same thing right here. And see dl over dx is equal to 0 because you want to find out the optimal point of this, such that the light takes the least path with manipulating theta I and theta j. So by doing that, we know that half and 2 gets cancelled on both sides, and we have this thing, right? So what is x over a squared plus x squared? Well, if you look in the diagram right here, since this is theta I, and this is 90 minus theta I, this is a and this is x, this is a squared plus x squared and square root of that by Pythagorean theorem, of course. And this is theta I, so since x is opposite of theta I, and this is square root of a squared plus x squared. This component is sine of theta I, and same thing right here, d minus x, and then b squared plus d minus x whole squared, right? This component is d minus x, and this is b, right? So this has to be b squared plus d minus x squared and the square root of that, right? Since this is theta j, this is opposite of this one, right? So this has to be sine of theta j. So sine of theta I is equal to sine of theta j, and sine gets cancelled, because if you do like sine both sides, then they cancel algebraically to get that theta I is equal to theta j. And that is my law of reflection video. I hope you like it. Please subscribe me for more videos. Thank you. Bye. So please subscribe to me.